There are a handful of different word problems that you can use a system of equations to solve. So here's a sample. A delivery truck is transporting large and small boxes. The large boxes weigh 60 pounds and the small boxes weigh 15 pounds each. There are 115 boxes in all. If the truck is carrying 4,200 pounds, how many of each box is it carrying? For this problem, a lot of the difficulty comes in coming up with the correct equations. So let's just look at the numbers we have. So we have 60 pounds, 15 pounds for the box weights. There are 115 boxes, and we're carrying a total of 4,200 pounds. Okay, so these pounds are probably all going to go in one equation, and then this is going to be our second equation. We have two unknowns here because we're asking how many of each box. So how many large boxes and how many small boxes do we have? That's our question. So there's two unknowns, so we're going to have two separate equations to solve this. All right, how many of each box are we carrying? Well, let's just look and see what we know. Large boxes and small boxes. We know there are a total of 115 boxes. So if we add up our large and small boxes, we'll get 115. Okay, so that checks that off for us. Let's try and combine all these pounds together to create our second equation. So 60 pounds is our large box, 15 pounds is our small box, and there's a total of 4,200 pounds. So 60 pounds times each large box plus 15 pounds times each small box is going to give me my total poundage in the box. There we go. We created our two equations. All right, to solve a system of equations, I like to solve by substitution, but you could also solve this by elimination with addition. You could multiply this top equation by negative 60 and add them two together. You could multiply the top equation by negative 15 and add the two together. Either way, you'd end up solving for one variable and then you'd have to solve for the other. You may need to watch the video linked here to remind you how to solve system of equations. All right, I'm going to solve this and rewrite it as L equals 115 minus S. If I subtract my S over to the other side, I know that all of this is how many large boxes I have. So I can replace the L in my first equation with 115 minus X. S. Sorry. I'm used to using X's, not different numbers, letters. All right, let's solve now. Distribute your 60. Combine like terms. Both of my S's are on the same side of the equal sign, so I can just add them together. Solve for S, so I'm going to subtract my 6900 over to the other side and divide by negative 45. And this is a word problem. S is telling us how many boxes we have, so we have 60 small boxes. All right, I need to know how many of each. So I know how many small boxes I have, so if I sub in a 60 in here, I'll know how many large boxes I have. And include units because this is a word problem, and L tells me how many large boxes I have. So here are my two answers. You can double check and sub them both into the second equation and make sure that it multiplies out correctly, or you can add the two together and make sure that they add to 115. Two mechanics worked on a car. The first worked for 20 hours, the second worked for 15 hours. Together they charged $3,875. What was the rate per hour by each mechanic if the sum of the two rates was 220 per hour? Okay, let's look at the numbers we have. We have 15 hours and 20 hours. We have how much total they charged, and we know that the sum of their rates was 220 per hour. What are we looking for? What is the rate per hour by each mechanic? So we're going to look for the rate of mechanic 1 and the rate of mechanic 2. Okay, can we come up with an equation to deal with rates real quick? We know that mechanic 1 worked 20 hours, mechanic 2 is 15 hours. Together they charge this much. And the sum of the two rates is $2.20 per hour. Perfect. That is a really nice starting place. So if I add their two rates together, I'll get 220. Now let's try and combine those other three numbers together to see if we can come up with our second equation, because we have two unknowns, the first rate and the second rate, so we need two equations here to solve this. All right, the first worked for 20 hours, so 20 hours times his rate plus 15 hours times the rate of the second person will give you the total amount that they charged overall to fix this car. All right, again, you can solve this by elimination with addition. Multiply the top equation by -20 or -15 to get rid of one of your variables. I'm going to solve that way. We might as well, right? Okay, so I'm going to multiply all of this by -20. So I'll distribute a -20 to everything. Okay. All right, now add these two equations together. So these R1s add to 0. And now solve for R2. If you divide by -5, my rate of my second mechanic is 105 per hour. This is how much he charges, so it's not just dollars, it's dollars per hour. All right, now that I know how much he charged, I can sub his number, 105, in here, back into this first equation and solve for R1. So 220 minus 105 would give me that the rate of the first mechanic is 115 per hour. Remember, the sum of their rates is 220 per hour. So we got this number from, so the units here of the sum will be the same thing as our units here in our final answer. And you can double check your answer. If I sub in 115 and 105 here into the second equation, it should add up to 3,875. For these last two examples, I'm going to just quickly set them up for you, help you figure out how to set them up, and then solve them super quickly. I want to more focus on setting up the equations. Two families used sprinklers. The Parkers was used for 20 hours, the Bryants for 30 hours. There was a combined total output of 1,550 liters of water. What was the water output rate for each sprinkler if the sum of the two rates was 64 liters per hour? Sorry, that's an L per hour. I know that doesn't look like it. All right, let's highlight all of our numbers. What are we looking for? Okay, let's come up with our equations. What was the water output rate for each sprinkler? So we want to know the rate of the Parkers and the rate of the Bryants. What do we know? We know that the Parkers were for 20 hours, the Bryants were for 30 hours. They used a total of 1,550 liters, and the sum of the two rates is 65 liters per hour. So we're trying to figure out P and B are the rates, the water output rates. So we've used up this number here now. All right, now we need to use the other three numbers here to come up with our second equation. So we have 20 hours that the Parkers was used, and we have 30 hours that the Bryants was used. So 20 times the rate of the Parkers plus 30 times the rate of the Bryants will give us the total amount of water that was used, which is 1,550. All right, we're going to solve this for P and for B, and our units for P and B are going to be the same as these units that are 65 liters per hour. There are 2 types of tickets. The combined cost of one advanced ticket and one same-day ticket is $45. 30 advanced tickets and 25 same-day tickets are sold. The total amount paid was $1,275. What was the price of each ticket? All right, numbers that we know. 45. We are looking for the price of each ticket. So the price of an advanced ticket and the price of a same-day ticket. What do we know numbers-wise? We know that the combined cost of one advanced and one same-day is $45. And A and S are the price of each ticket. So if I combine the cost of A plus S, I'll get $45. So dollars will be our units for A and S. All right, let's use the other 3 numbers here to come up with our second equation. 30 advance tickets were sold. 25 same-day tickets were sold. And that tells me the total amount of money that they made. I don't need a number sign here. The total amount of money that they made here. Remember, the units for 45 are going to be the units for S because this is the total price or the price of the same day tickets. Now that I know that this is 15, I can sub in a 15 here. And I'm good to go.